So this is the same challenge problem that we finished class with. I'm going to start it over because I don't exactly remember where we left off, and it might be helpful anyway for some of you. But jump ahead because I remember we got to the place where we knew where the derivative was equal to 0 and we tested all our critical points. And so we're going to be looking for max, min, point of inflection, increasing, decreasing, concave up, concave down, any vertical asymptotes. I can tell one already. When x equals 0, I will have a vertical asymptote because that's where I'm dividing by 0. But that's jumping ahead. G of x is equal to x minus 8x to the negative 2. Making g prime of x 1 plus 16 over x cubed. I'm just going to take the second derivative while I'm at it. This is also 16x to the negative 3. Those are the same. So my second derivative will be, well, the derivative of 1 is 0. So negative 3 times 16 x to the negative 4, or the second derivative is negative 48 over x to the 4th, and my first derivative was 1 plus 16 over x cubed. So my critical points will be when my first derivative, g prime, is 0 / undefined. And so we will set 1 plus 16 over x cubed equal to 0. And for undefined, it's pretty easy. We're going to be undefined when x equals 0. And again, that's that vertical asymptote. But we're also going to be able to tell something about our increasing and decreasing behavior. So as I continue on here, subtracting 16x cubed will make it negative. So I'm just going to say, hey, this is equal to a negative 16 over x cubed. I'll cross multiply and get x cubed equal to negative 16. X equals the cube root of negative 16, which is also negative 2 the cube root of 2. So now I'm going to do my line test to see where my derivative is positive and negative. So I know key points are 0 and negative 2 cube root of 2. Well, we decided that something smaller than this would be the cube root of negative 8, because negative 8 is less than 16, and the cube root of 27 negative would be the other side of this critical value. So I'm going to test 1 and negative 3, negative 1 and negative 3, because that's all the cube root of negative 27 is negative 3. So when I test A, and we'll test over here at positive 1. So now we'll do it. When we test 1 in for x cubed, we get 1 plus 16. Well, that's positive. When we plug in negative 1, we get 1 minus 16. Well, that's negative. And so far, everything to the right of 0 is positive. Anything to the left of 0 is negative. And now we're going to have to check negative 3. Well, 1 plus 16 over negative 27, that is still going to be greater than 0. So this will be back to positive. And so far, if I were to make a little graph, I've got a vertical asymptote we know at 0. And we have something at -2 cube root of 2. And at this -2 cube root of 2, my graph is changing from increasing to decreasing. So this must be a max. We don't know where the max is, but we know we have a max, and we know that our graph increases up to it and decreases down from it. So we will continue on and say, hey, like I know I'm going to go down toward my vertical asymptote. And I know that I increase on the other side of my vertical asymptote, so I bet my vertical asymptote looks like that. We can draw that much so far. Now let's take a look at our second derivative. Our second derivative was -48 over x to the 4th. If we see when that equals 0, slash undefined. Well, there's no way to make this 0 because -48 is in the numerator. But there is a way to make this undefined, and that is with x equals 0. So this is a possible point of inflection, but we will need to see if it crosses or bounces, so we'll do another sign test. This first one was at f prime or g prime of x. This next one will be g double prime of x. So as I do my sign test at 0, let's just pick 1 and -1. Is -48 over 1 to the 4th, oh, that's negative. How about -48 over -1 to the 4th? Well, that's also negative. So I do not have a point of inflection, but I am concave down on both sides, and that seems to make sense because notice what we have here. This appears to be concave down. This appears to be concave down. But there's still a little bit more that I can find out. And now we're going to go back to our limit calculus. What happens as x gets very, very big? Well, let's look at the limit as x approaches infinity of our original function g of x. Well, our original function was x minus 8 over x squared. X minus 8 over x squared. So when I think about this, this will be a huge number minus 8 over huge squared. Well, that will become 0. So the limit as x approaches infinity is just huge or infinity. So my graph, as I continue on, well, my graph is going to just go up and up and up. Now let's look at the other direction, and keeping in mind it is always concave down. So we can clean that up a little bit. It's going to go up and up and up, but it's always going to slightly be curving downward because we never have a point of inflection and shoot up like that. Will not look like that. Now let's take a look at the limit as x approaches negative infinity. We're going to have negative huge minus 8 over negative huge squared. Well, with that denominator being so big, that will again be 0. So this one is negative infinity. And so this guy will also go toward negative infinity while always remaining concave down. The only other things we could do is we could look to see, does the graph, the original graph, have any zeros? So if we say g of x equals x minus 8 over x squared, well, when is the y coordinate 0? Well, let's see. That will be when x equals 8 over x squared. Cross multiplying will be when 8 equals x cubed, or the cube root of 8 is 2. So now I know this 0 is 2, so it's making more and more sense. The only other thing that might be interesting, what is the y value of this relative max? Well, let's find out. What is g of negative 2 cube root of 2, which was really the cube root of negative 16? Well, we will have negative cube root of 16 minus 8 over negative cube root of 16 squared. So when I do that, this is again that negative 2 cube root of 2, which is between negative 2 and negative 3, somewhere in there. So as I take this negative 2 cube root of 2 and I square it, this will give me, squaring negative 2 is positive 4, and when I square 2 I get 4. So now we're looking at the cube root of 4. So we have negative cube root of 16 minus 8 over 4, the cube root of 4. We're going to go to our calculator at this point because anything else would be kind of crazy. Looks like that's about negative 2.5, negative 2.520. So this gets as high as negative 2.520. And again, the x was that negative 2 cube root of 2. So that's how, without using our calculator, except at the very end, to just kind of come up with a decimal approximation of that number to save us a little time, we did this whole entire graph, the max, the asymptote, the concavity, the zeros, everything no calc. Pretty cool. We're learning a crap load about math and calculus.